Hey guys, what's going on? Welcome to the fourth episode of Refactoring an Android app with our friend. No, he's not here. He's online. Rakesh. How are you doing, Rakesh?
I'm good. How are you?
I pointed to the left as if I were to introduce you, as if you were sitting here, as a kind of joke, but you're not here. You're online. Did you meet with your YouTube friend in the LJC community?
LJC. No,
Ah, you didn't. So you have a community over there which just deals with Java?
just deals with Java, just deals with Android. We have every community for everything.
That is so cool. Here in
Well,
Lebanon,
living in a big city, right? So,
yeah.
yeah.
So last time did some we converted the existing tests that we had. We had mocked them ourselves, and we converted all of them to Mockito. So they now use Mockito library to mock, and we added some rules to them so that they do exactly what we wanted, but they became sort of one-liners where you have your setup method. You could paste whatever you used again and again in that setup method, and then the other methods would just take that whatever you used inside the setup as for granted and use them to run whatever they want to run. We could take a look at it again. Today we're gonna do something different. Well, it's not different. Just we're gonna have these tests return exceptions or errors in case the repository or whatever they're talking to, whatever they're testing, return an error. Because here we just handle the empty and the full case. So you can go ahead, Rakesh, if you want to tell us more about this.
Okay. Before we go into exceptions, I just wanted to expand a bit more on the Maketo stuff from last time. I found this excellent video online from Devox called Testing Made Sweet with a Maketo. And I really suggest having a look at that because the guy explains it really well. And especially if you understood the video that we did when we did the episode, it should all be really obvious. You understand what he's saying, and he then adds on top of it as well, talks a little bit about the advanced use cases and stuff. And so I really recommend that. And obviously his language and everything is much better than mine about using the right terms for everything. But one thing I did pick up from that video was how to initialize Maketo using a rule. So I think we should do that as well. Instead of doing this, we do this. Now, it doesn't make a difference functionality-wise, but what it does mean is that we're free to use another runner as well as Maketo. And we need another runner if we were going to use the Android SDK for our tests.
What
We aren't
exactly
planning
is a
to.
runner?
So a runner is like a plugin for JUnit, right?
Mm.
So it tells JUnit that it needs to go and instantiate and create and configure something else. You know, in our case, it's Maketo, where it's Maketo is one of them. If you want to use the Android SDK to run your tests against instead of the vanilla JVM, then you would say Android SDK there as a runner.
So
So
you
just
have to
telling
run the
JUnit
test
how
on
to.
the phone?
No, it doesn't deploy it. It 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 Google created a version of the SDK which you can compile against, but
Mm.
you can't run against it, right? If you try and call any of it, any method on there, like there was some packages inside the SDK that Android have, which were quite nice, which I thought would be really nice to use. I think there was like one for string,
Mm.
where you can do simple validation and stuff like that. And unfortunately, they're not available in normal Java. Oh, I got a better one. Google created some specific collections. Did you ever see any of their collections that they created? There was one called Sparse Array
Yeah,
or
I've used
something.
that.
Yeah, but
Sparse
that's
array
not.
list.
Yeah, but that's not available in the JVM. It's only available in the Android SDK.
It's Android, yeah.
Yeah, and if you had some functionality that used it, then you could only run that test against the Android SDK, right? So your choices are run it on the device or run it against the mocked version of the Android SDK that they give you.
Mm.
But if you do, it has no implementation. It just blows up, right? So then you'd have to
Oh.
mock its behavior.
Oh,
But
you have
that's
to write
another.
another like data structure that behaves like it.
Yeah, so basically they've given you the interface for it, but they haven't given you any implementation. And they've
So
done that for loads of classes in the Android SDK. So it's not, so you end up having to mock it. So then that's when a lot of people use Maketo to then say, okay, when I use this and stuff.
so
But I
this
don't think,
this this line 24,
yes.
this is a runner now.
It's actually called a rule, not a runner.
Okay.
And the rules run, they have a life cycle and they run just before the tests and all that sort of stuff. So I recommend, having a look at the JUnit website and understanding the stuff there, how to use them. But this is provided for us. It came with Maketo. And if you just do this, then it's you still get the same functionality. It still works the same way.
As opposed
The other
to, yeah, go on.
I'm just going to say the other thing I wanted to mention was thanks to one of our viewers on the YouTube comments page, I found the presentation plugin. So now when I use the keyboard shortcuts, it will appear at the bottom of the screen.
Yeah, I saw that.
Yeah,
It's
that'd be
pretty
nice.
cool. So it appears to you too, huh? Like
Yeah.
it doesn't detect if you're in preview mode or something.
I don't know.
It's
I
always
haven't
on.
Yes, there's no off button. I don't think. I've not
Okay.
seen one. So we'll see how it goes. Right, it's on anyway. Anyway, this test is working, so it's fine. So this little minor change, I think I'm probably going to use this as a template for tests going forward from now on.
Which one?
This one here, where you have the rule like this.
Uh-huh.
Initiate Maketo,
Uh-huh.
and then the annotation use of Maketo. There's a few ways you can use Maketo, but personally, I think this way is
Seems
quite
the
good.
most simple, yeah.
Yeah.
All right.
Okay, so back to what we're going to be discussing today. So we have a books repository, a database books repository, and we had a bit of a conversation about what if it goes wrong.
Yeah.
And if it goes wrong, we're returning an empty list. But let's say we don't want to do that. Let's say what we want to do is, so if there's some error with talking to the database, what we want to do is we want to show a toast to the user. What do you think?
Yeah.
Yeah.
First, we're gonna have to return the exception so that we can catch it on the other end.
Correct. And now there's something, I think actually every week, every time we do one of these videos, I'm going to give you some homework. Okay. I've already,
Okay.
I've already given you the homework about watching that Maketo talk. It's 50 minutes and it's good.
It's for me?
For you and for people watching this video.
I mean, am I included? Okay.
You are definitely included.
And do what with the video?
Reach enlightenment, obviously.
Reach
right?
enlightenment. Okay, that sounds like a
Yes.
reasonable goal.
That's what we're here to do, right? We're here to become better, right?
Yes.
So you will be better after having watched that video.
All right.
In the world of Maketo. Okay,
Will
cool.
do.
The other thing is, back when Java was created, the creator of it created something called checked exceptions, right? But that wasn't the only type of exception. There were also runtime exceptions. Okay?
Those are the ones I know.
Right. And so the thing about checked exceptions is that you are forced to deal with it. Okay, so some piece of code that you're calling says it throws some exception and you have to deal with it. So we ran into that here, didn't we, with this thing here? It says you have to catch an SQL exception.
Yeah, you have to surround it. It won't compile.
It won't compile, right? And there's been a lot of controversy about checked exceptions, right? And a lot of people have decided that they're not very good. Now you have to come to your own conclusion. I came to my conclusion a long time ago, like 10 years ago, that they were just a pain. They're already, in the JDK, so there's not much we can do about it there. But with my own stuff, I don't like checked exceptions. And what I much more prefer to do is to create my own runtime exceptions.
But the issue is, yeah, it makes sense. But the issue is that sometimes you run a piece of code and it returns an exception. For example, dividing by 0. It's not a checked exception. It's not getting caught at compile time. You get a runtime exception. So now you have to go and surround it. tell me from the beginning. I'll surround it. It seems easier.
Yeah, if you want to surround it from the beginning, that's fine. If you think there's any opportunity for it to go wrong, I mean, a lot of people, they sort of like do enough validation that they're more confident that the code won't. But like what we're going to do here, though, is we're
Basically,
going to
it's
run.
like basically checked exception. What you're saying is like if you do your homework and protect the code from failing, checked exceptions will start seeming like barriers or like padding around a playground.
Correct. Yeah,
Yeah,
they
you
just
don't
get in
want
your way.
padding around the playground. Just write your code correctly.
Yeah.
Okay.
And normally we know the entry points and exit points of our applications. We sort of know where, if a lower layer was to throw an exception, we sort of know where it will go to for us to then catch it and deal with it. Make
Okay.
sense?
Yeah.
Okay. So we're dealing here specifically with this, and this could go wrong, right?
Mm-hmm.
And we were returning an empty collection if it goes wrong, but I don't think that's a good idea. What we should really be doing is throwing a runtime exception.
First of all, why is this not a good idea? Because we already have a case that does return empty lists, so now we can't figure out whether it was wrong by error or just empty.
Yeah, there is a difference between you have no records in the database yet, or there is no database, or there's some problem.
Okay.
There's some problem talking to SQLite or whatever,
All
right?
right.
As a user, you might not be able to do much with it, but you should
Uh-huh.
at least let the user know that there is some issue that meant that it didn't work properly,
Okay.
right?
So return E.
So I don't want to return E, because then the other thing is, so we were talking about the architecture of the application and trying to keep as much in vanilla Java as possible. Okay.
Okay.
Now the classes on the edges that deal with the real world. So this is a class on the edge dealing with the real world, which is the database in this case. Yeah.
Mm.
We want this class to only be the one that knows about the real world and knows about the specifics of the real world. Now SQL exception is being created by SQLite.
Mm.
So we don't want that exception to escape from this class.
So,
Make sense?
okay. So
The
you can.
class.
So you want to return a generic exception.
I do. I want to create a runtime exception.
Okay. Like
Yeah?
throw new runtime exception.
Yeah, we could do that. I
Oh.
mean, if if you find that you want to classify these exceptions, which happens a lot, especially with business rules, like you can't have a negative balance or something like that, then it makes sense to create an actual class that's a subclass of runtime exception.
Okay.
Yeah, and then you can actually create a class for it, give it a proper message. You can then check for it, and then and it's also documentation as well, right?
Mm.
But what we want to do is we want to do throw new runtime.
Oh, I was right. Okay.
Exception. Say, for example. Okay. Now, thing is, we haven't written a test for this because I said to you it was very difficult to write a test for this. But my question to you is, how are we going to manually test this?
Okay. Okay. Don't initialize the database helper.
Like
Yep, that'll do it. Initialize it as null. Yeah, I mean,
okay.
or above in the declaration.
Yeah. Well, what I was thinking is, what if I did this? What would happen?
Yeah, it would be an exception.
Because it's looking
Because
for that field.
no field order X.
Right.
Would it be an
And it should
exception?
throw
Yeah,
an
it will be
exception,
an
right?
exception. Yeah.
Okay. So let's try that. That's quite an easy one, right? So our presenter is going to call this, and it's probably going to blow up. Shall we see what happens when we actually do it?
Yeah, we're gonna.
Let's do it then. Let's just see what the behavior is of the app when we do that. Obviously,
Of
we're
the
expecting
app?
static trace. Yes, of the app. Just see what happens.
Okay, like in real life. Oh, without the test. All right, yeah.
Yeah.
So where are you gonna see the app?
I'm trying to bring my emulator on screen, but it doesn't like it when I'm in full screen. There we go. Do you see it?
Yep.
Okay. Let's see what happens when we launch it.
So, but you changed something. Oh, the presenter is live. Yes, okay. You know, your
And the
friend,
presenter has.
your friend
Sorry,
told
my
me,
friend.
your friend told me to review the code before each session. So now I
Oh
got
yes.
mixed up. Like, where did he change? He's changed inside the presenter, which is actually live. It's working. Yeah, of course. Yep, that's it. Unknown column.
Thing is, though, what exception did it throw?
Runtime exception.
Illegal argument exception.
Oh, but it said runtime exception above. Yeah, this is the root one, not the above
Yeah.
one. Okay. Illegal argument exception. Okay.
But I don't think illegal argument exception is a SQL exception, right?
Don't know.
I don't think so. What we could do is we can wrap it, right? We can wrap exceptions, I believe.
Mm.
We can do that, right? See what happens when we do that.
So if the casting, like now it's gonna fail to make a new object out of this exception, or what are you looking for to see now? What's
I want
supposed
to
to
try and
happen?
understand what was thrown, because it says SQL exception there, right? But I didn't see any
Yeah,
SQL exceptions in here.
but you didn't catch it.
I did catch it initially. It
No,
says
it's
SQL exception.
stopped.
Now I've changed it to exception.
But the app stopped. If you caught
Yeah.
it, the app would not have stopped.
If I'd have caught it, the app would not have
It
stopped.
wouldn't have crashed.
If I'd caught what?
The exception.
But okay.
It would just
Okay,
print
so
it down there, and the app would keep going.
Okay, can you see how the exception being thrown
Yeah.
is... So there's my top level runtime.
Yeah.
But the one that was thrown below it was a illegal argument exception, right?
Yes.
Okay. But not SQL exception.
No.
So they're making you catch a SQL exception, but it could throw something else.
Hmm.
It could throw a runtime exception,
Hmm.
which is legal argument exception. Ah, that's very interesting, isn't it?
Did you what you want? Did the stuff you want to run or you want to test? Did it work? Like, did it make a new wrapper?
Was this thrown, you mean?
Yeah. Was this? Yeah.
I'm not sure, you know. It's not obvious. Let's have a look, see if we can see that anywhere. Let's have a look. Because I'm hoping that because it's catch exception, it'll catch any exception. Right? But because it was SQL exception, I thought it was being caught, but it might not have been. It might have just because it didn't match that and it went up, bubbled out.
Yeah. I'm sure it wasn't caught. Because catching an exception prevents the app from crashing and stopping and leaving the activity.
Well, not necessarily. It depends on what not returning from, not dealing with the exception means.
Oh, now, yeah. Now you threw a new one. Yeah, that's why. Okay, yeah, it did get caught.
It did get caught. And so my new one is there. So, you know, I'm just doing this to understand more about what's going on, right?
Okay.
So that's fine. So my new one is caught. But the interesting thing about doing this, right, is that what I'm saying here is that catch any exception, and then throw a runtime exception.
Okay.
And now, because this is general Java, this goes up, but it's not specific to the database. So it means my core code still doesn't know about the specifics of SQLite.
That's
which
true.
is what I'm trying to do. But like I said, normally what I do is I would create like a specific exception that's part of my domain for my application that I'm working on.
Yeah.
Okay, let's leave that there. And we saw that the app basically just crashes, right? Which is not surprising. So what we want to do really is we want to make the presenter resilient to errors being thrown, right?
Okay.
And deal with it. So what we'll do, because we test drive our code, right, is we're going to create a test, and we're going to deal with the case where we have an exception being thrown by the repository.
Okay, so each thing that can happen in the world is a test.
Yes.
Okay.
And if you think about it, what you're basically doing is this is a spec of the code.
Yeah.
Right?
This describes what this code is able to do. Either return something or should do. Okay.
Yeah, should do. Because I mean, if your customer comes to you or your boss comes to you and says, you know, we want to do this functionality, you want to break it down into little pieces. Okay, so if this happens, then this should happen. If this happens, then this should happen.
Man, you should know you should know the internals of what's going on. Like every single thing that this code can do, you should be aware of it to write tests.
Yeah, but then what we're doing by doing test driven is that we're using the tests to help us write the code. Okay? Because if you just end up writing a whole load of code without any tests, then you have to spend ages reading it to try and work out what it's trying to do. Whereas here, we're using the tests to write the code. It's very different, right? We only write the bare minimum we need, right?
But how is this gonna tell you how to write the code? This is imaginary. You're creating these cases from your head. How are you gonna implement? Like for example,
do you really think I'm making them up? I mean,
no, they're real. They're real. But for example, what I mean is that in a new case where you have some other requirement, all right, something complicated. If you don't understand what that English requirement means, you're not going to be able to write the tests. And if you do write them,
guess what? Yes, you're right. And also, you're not going to be able to write the other code either.
The other code either?
Yes.
Ah, so I'm wrong.
Well, I mean, what you just said doesn't make sense, right? I mean, well, it makes sense, but then you can't write the proper code either. You can't write the test, and you can't.
Yeah, you can't write anything. Okay.
You can't write anything because you don't understand how it works.
How it
and
works.
What we're doing here is we're breaking it all down into little pieces to try and understand.
Here's what I mean. What I mean is that writing the tests isn't gonna help you understand the code if you don't already understand the requirement completely. So if you understand the requirement completely with English, exactly how it should, what it should do and everything, then you have your work cut out for you. You already know what it does. Like writing tests is just making sure. I don't yet see how it's a method of clarifying what's going to be written. You already should have that while coming here. It's not going to help you understand what's going on.
Let's say you understand the functionality in English.
Yeah.
Okay. You sat down, you spoke to your product manager, you spoke to whoever, and they told you we want to do X, Y, and Z, right? And it all makes sense to you, right? Now, they told you, right? And in 6 months' time, they get some other guy.
Okay.
Now, what I'm trying to explain is that what you understand that the app should do, you end up and you go in there and you go and write some 2,000 line activity that does it, right? Without tests.
Okay.
Now, you leave, or more likely, 6 months later, you have to come back after you've been working on loads of other projects. You've barely remember this one. Then you come back to this one. You've forgotten the details of that conversation you had. All you have is the code. You go into your 2,000 line activity and you stare at it to try and work out all the functionality that it's trying to do. You're going to struggle.
Yes.
Right. Whereas if you took this approach and you broke it down into logical units like these tests, it will serve the purpose of helping you to write it because you came and you defined units of what it should be doing, and this is your documentation.
Yeah,
You
that's
come
the.
back
Mm,
and you look at this, right? And you look
mm,
at what it says, and then it starts working out. Okay, because very much the activity code is how to do something,
yeah,
right? But you know you want to put it into the context. So here I've got should handle no books found, right? Or should pass books to view.
yeah,
So you want to know that the presenter deals with getting books from the database and sending it to the view. But you're not too bothered at this stage about how that works. You
yeah.
just need to know that's a piece of functionality that it does.
I see.
And then you can start drilling into it to find out how does it do that.
Yeah, many times I hear people saying that testing it's in and of itself seems useless for one person. But if you have
Yes.
two people, even if the second person is you in the future, that's when it
Mhm.
shows its usefulness. Because right now, at this
Documentation. Yeah.
moment, I know what's going on. Basically, you can argue that I don't need a test for right now, this moment. But tomorrow, I need it. The day after tomorrow, I need it. Yeah,
Yes,
okay.
exactly. Exactly.
Okay.
Now, let's write this one. So now you can see when books repository dot get books
Is equal to.
is what? Where?
The return thing should be equal to an exception.
Well, they've got this thing called then throw.
But you're saying what here? I get
Let me
books then
just finish
return.
writing.
Okay.
Okay. So remember these whens, right?
Yeah.
These whens. What they do is they set up the mock to behave a certain way, right?
Okay.
Okay. So if you look, what we're saying is when the book repository.getBooks method is called, then throw an exception from it.
Oh, we're imitating
So
the
here,
behavior. Okay.
yes, here we did it. We actually did it,
Yeah,
right?
yeah,
We
yeah.
broke the code, right? But for the test, we want to do the same thing,
But with
but
a
we
test.
want to, but with a test and with a mock, right?
Okay.
So you need to tell the mock to blow up.
Yeah.
So that's the syntax. We're saying when you get called, then throw a runtime
It's
exception.
so easy,
Okay.
man. You just have to remember what.
You do it. I do it every day,
Yeah.
right? It's just second
It's really
nature. It'll be
easy.
second nature to you, and you'll be
Do the
fine.
same. Okay. Verify.
Okay. Now,
Now.
right now,
Now you need a method that shows a toast in the in the what?
in the activity.
In the
So the
activity.
question is,
In the
what should we call the method on the view? And do you want to pass a message or not?
Okay, pass a message, yeah. From the you pass a message from the one that was given to you by the runtime exception. Oh, we talked about that using the variables above and the when. Yeah, you can't do that like easily.
I can get the
Like the
message
boom.
from the exception. I can get the boom.
Okay, that's the
I
one you
can
have
get the
to get.
boom. The only problem is sometimes a lot of these exceptions are very, cryptic. They don't mean anything to the user.
Okay.
So sometimes, if you're going to give them a message, you might want to give them
Yeah, in the in
something very
the in the
simple.
logical side of
Yeah.
the app. Okay.
I think for this though, we don't really need a message passed because we're not going to ever change the message.
Okay.
We're always going to have the same message, so then
Yeah,
it
that's always yeah.
might as well be a constant in the activity. So basically, all we're saying to the view is show the error toast.
Okay, display error toast.
Display error. I don't like to use too many Androidy things here
Okay.
because it might be a toast now, but it might be a dialog
Alert.
later.
Yeah. Okay. One
Yeah. So
second
just
though.
display error.
When you say verify on view, it returns. What does verify do exactly?
So this is checking whether we called methods on the mocks.
So the dot refers to the view now.
The dot refers to the view, yes.
Yeah, but it seems like it refers to the object returned by calling verify on view.
It might do, but you know that's a bit like how the mocking libraries work, and you sort of have to look beyond that. And you know, Uncle Bob doesn't like it at all, and he chooses not to use mocking libraries because
This
he
one?
thinks this syntax. This one, and also another one called what's it called? There was one before JMock. JMock, yeah, JMock. That was even funkier syntax.
Okay.
But you know, you have to do these funky things to be able to do these funky things, right?
Okay, that's right.
Yeah. So
Cool.
anyway, this test I think looks good.
Yeah, let's
Yeah.
go to the view and make the method. Right, and we implement it in the activity.
And we implement it in the activity, which should now break. So let's just do this. If I make the project, it should tell me that the activity is now broken because we haven't implemented a method on here. And it does. Implement methods, display error. Right. Do you remember the syntax for toast?
Yep.
Was it?
Just write
Was it?
toast with a capital T and tab. Tab. Okay.
Oh, nice. Okay. All right. We knew that wouldn't work. Where's our code?
Above. No, what's the first error?
It's this constant thing that's always there.
Oh,
It's a real
right,
pain.
right.
Yeah.
We'll get to that.
We'll get to that. And the rest, I think, is where are you, Mr. Toast?
I'll just find on display error. Yeah.
Got it. So error accessing data. What do you think?
Yep. Okay, that should do it.
Okay.
That should do it. Yeah, that should do it. Yes,
Right.
it should do it.
Now we should run our test.
Yeah.
Right. We always run our test. I mean, we haven't changed anything in the actual production code yet to make this test pass. So it should fail, right? Because we haven't changed anything. So we know that when this happens, it could blow up, right?
Mm-hmm.
And what we want to do is want to wrap this.
Try catch.
Try catch. There we go. Try catch. And if it blows up, we want to do view
Dot display error.
But we don't want it to then do any of these, right? So this block needs to move
inside,
up here.
Yes. Okay.
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 All right. Book list equals null. It did that for me. Then we do that. Redundant. Fine. Okay, should we run our tests?
You should run your test. Yes. Okay, so you throw this, fine.
Yeah, I'm not throwing it right now though.
Yeah, okay? It's not right now.
Setting it up.
Yeah. Okay, when does it actually happen?
Right, then what happens? Think about the thread that's running, okay?
Yeah.
The test thread comes in, it does this line.
Okay, it knows. Okay, when you call get books, I will throw you a new exception. I promise. Now you go. Here. You go load books. Here. Yeah.
And then it comes here.
Yep. There's your get books.
Then there's your get books. What
you catch up, cut. Okay.
So it won't even go to line 23.
No.
It'll go straight here.
Yes, and you go back there, having called this view.display error, you verify it here.
Yeah.
Yes, it is complicated. The whole, yeah.
I don't think it's complicated. I think you just need to see it.
Yeah, to see it. That's what I mean. For it to flash in your head.
Yeah, I don't think you're quite seeing the object graph. All I'm saying is...
No, I'm seeing it now.
You're seeing it now? Okay, yeah. Cool.
It's just an issue of where the exception happened, you know?
Right.
I mean, it's right there, but I didn't see the line, the end of the line. I didn't continue it in my eyes. I just focused on get books. There was a continuation for it. Okay.
Right. And remember, because we already have the existing tests there
Yeah.
and they're still passing, we can be confident that we've done the right thing. And our presenter deals with 3 scenarios now.
Yes.
Okay.
Okay.
So, shall we hook it up and see a toast?
Yes.
Okay. So, if we've done it correctly, we should see a toast.
Oh, we did.
We've never seen a toast.
We've never seen a toast, but we did say what we want to have happened over there.
Yeah. But it's only going to happen
Yeah.
if our presenter does the right thing. What is wrong with this thing? What the hell?
Why is it doing that?
I have no idea.
What if you turn it off and back on? Oh, there we go.
There you go. I used to enjoy using Genymotion more, but
Yeah, I like the animation more. Yeah, sorry about that, but I don't know. Like, yeah, maybe I need to review. But this one was new. I was not expecting something like this. Maybe now it clicked. Before it wasn't, and I was just saying that. Yeah, I saw
Eric.
it. Yeah.
Okay.
We can launch it again if you want.
No, I saw it as long as you saw it.
Yeah.
Okay, but like the only reason it did that is because
Because of the
when
order
we run it
X.
on the order X is the reason why
Yeah.
it's doing it. But we wrote the test to make sure that we would get that behavior when this breaks.
Yes.
Make sense?
Yeah, you sort of like in the higher like the 10,000 feet overview of testing itself, you're sort of creating a new app based in this new language of new way of talking, you know what I mean? That imitates
Yes.
your current app without the actual know-how of what's actually gonna happen inside. It's just that the bigger headlines are working. It's not the bigger headlines, it's even detailed, you know? But it's just like a copy of it.
Yeah.
Plus explaining the MVP. That's why it's complicated, you know? I have to grasp the testing itself, which I have no idea about, and the MVP, how they talk to each other.
Yeah,
So it
true.
is a big chunk. Yeah.
It is a very big chunk, which is why probably that guy was saying you should look over the code just before,
Yeah.
just to get it in your head. But I think, you know, if you could just apply it to your current working environment, you know, just see how you can introduce it in stuff that you work with.
Yeah.
I mean, the MVP thing, you know, the M part of it is up to you, and I'm showing you my way, you know. But you know, having the view and as an interface and all that, and then getting to start writing tests, I think, yeah, it's you know, it takes time. It takes time, dude. It takes time,
Yeah.
but you get there in the end. Anyway,
Okay.
I think we've got it all working.
Yeah.
I'm wondering whether we should just do a Gradle W clean
For what?
test. How many tests have we got? Just the one.
Yes.
There's probably not much point doing that, right?
Yeah.
So
Think that's
so
a
now
wrap?
I think that might be a good place. But before we do, right? Can I just talk about one thing?
Sure.
I just want to talk to you about solid principles, right? Let's go here. Now, these are like some really good high level, you know, like the 10 Commandments type thing.
Yeah, I've heard of them.
So we want to try and follow these where we can. And as we touch on them, I think, you know, I'll mention them because we have already touched on the most important one for me, which affects my code all the time. And it's the first one, single responsibility principle, where you say a class should only have a single responsibility. And that's a really big one. And that's a very general way of saying just divide up your crap, right? So like it's not doing too many things. So if the chance of it going wrong isn't going to be because of, you know, X, Y, and Z, it's going to be because of X, or, you know, just keep everything divided up and you should be good. I don't know about open close principle is going to be something we're going to hit. Liskov substitution principle is where we try to use the interfaces instead of the low-level ones.
Mm-hmm.
Yeah. Objects in a program should be replaceable with instances of their subtypes without altering the correctness of that program.
Okay.
And interface segregation principle, many client-specific interfaces are better than one general-purpose interface. So, we had the view, and let's say we end up with like loads and loads and loads and loads and loads of methods. It's
Mm.
basically saying maybe you should divide it all up a bit more.
Mm.
Because if you have one huge one, it's gonna cause lots of problems with change.
Is that what the MVVP was made for?
No.
Okay.
MVVM, you mean?
Yeah,
No. No, that's
because
something else.
you end up. I was reading somewhere a while back where you end up with also God views. You know?
If you're talking about MVVM as in data binding, or
No, it's the problem with having like so many methods in the view.
yeah,
Because you're basically
yeah,
doing the same mistake now as you're trying to avoid them being in the activity. Now you have them all in the view. So you end up with a huge view.
yeah, which is not great either. Which
Mm.
means that, which implies that only one class is implementing that view, and it's going to be doing a lot.
Mm.
Is that right? Or maybe we should be breaking it up.
Mm.
So yeah, something maybe it'll come up. We'll see. And
Okay.
this dependency inversion principle isn't dependency injection.
Yeah, yeah.
Actually depend upon abstractions, not concretions, which sounds a lot like this one actually, the Liskov substitution
Yeah.
principle. But again,
Who created these?
this one, yeah. I mean, if we come across these, we should talk about them.
Who created these?
Uncle Bob.
Ah, one
I'm pretty
guy.
sure it was Uncle Bob. Well, I think,
How can one
he.
guy do so much, man?
Well, I mean, he's not Liskov, right? Liskov was some woman, and she came up with this rule. And Uncle Bob, I think, put all these rules together.
Hmm.
He didn't create the individual rules; he just brought them all together and created solid, I think.
Yeah.
Look, 5 basic principles of object-oriented programming and design.
Hmm.
So yeah, so I just wanted to mention that, and make sure you watch this video. It's your
Okay, I
homework for
will.
next time.
But
Okay,
does
cool.
it get too complicated or something?
You come back and you tell me. I don't think it did.
Okay.
Yeah.
Should we? I just had an idea right now about effective Java.
Yeah.
It's a famous book, guys, about Java. It's for not. It's not for beginners. Beginners. It's for people who are familiar with the language, wrote a couple of programs, what have you. It mentions stuff that's really. Well, it's a classic, and everybody swears by it. You should read effective Java. You should read effective Java. So I was thinking like maybe if we can get a vote or people just replying with what they think about if we take excerpts from it and see what they mean, like explain stuff that I believe is hard. Maybe we can see if other people believe it's difficult as well. Maybe you know more about it because you've read the book. What do you think? Should we like ask them? We're asking you right now.
Yeah. I mean, we should always try and get more and more feedback.
Like, would you be willing to do something like that if the chance
I
occurs?
think if the chance occurs, yeah, we can cover it. A lot of it is just common practice nowadays that's in there.
Mm.
And when you get ugly code and you're wondering, oh, why is it so ugly? That book has a lot of answers,
Mm.
and also helps you to design your code better from the beginning.
Mm.
So yeah, but I mean,
If it comes up, okay,
if viewers have got specific questions, feel free to ask them, and do our best to answer them.
cool.
Yeah.
Hopefully we
So
get what?
I was just going to say, I think we've covered enough for today. I don't know if you want to do a sneak peek about the next episode.
Do you
What
know
we should
what
do?
it's about?
Well, I was thinking we're at the point now where we could probably introduce a bit of RX and do this
Right,
on a background thread.
right. Yeah, because the database code and the talking to the database is still on the main thread.
Correct.
That shouldn't happen. Okay, sure.
And I can do the RXy stuff from first principles.
From what?
From first principles means I'll take it from 0.
Okay. Cool.
Just start from the beginning. And what we can do, we can use JUnit, and we can write some code, scratch code,
How much
to
exactly do you
explore.
know about RX? Like, how deep did you go?
I wouldn't say I'm that far advanced, but I know the basics enough, and I know the scenarios that come up a lot, such as this one, which is very basically make a request, put it on the background thread. When it comes back, go back on the main thread.
Yeah.
I can do that,
Which I've
and I
done
use it.
wrong in my current code.
Yeah, your current code wasn't correct, and I
Okay.
can show you the new way. And I use it a lot for network code with retrofit,
Yeah.
where it's really nice. You can do concurrent requests and combine results, and and JSON parsing with it and all that. I love that. That's where I really like it. Where I would also like to use it, and maybe we can explore it later on, is to use RX Android.
That's the one I
So,
use.
no, use RX Java. When I say RX Android, I mean the widgets are all reactive.
What widgets?
The buttons and
No way.
edit text.
They
Yeah,
can be RX'd?
that's RX. That's the RX Android project. Yeah.
Oh my god. I've been using
Yeah.
RX Java and thinking that I was using the Jake Wharton one. The Jake
No.
Wharton one, RX, he made RX Android, no?
I think so. Yeah. I
Yeah.
think he was the one. Yeah. 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 He wrapped them. Yeah.
I'll tell you a funny thing that happened with that off the
Hmm.
air, because
Yeah.
that's a really big confusion. Okay, so you can have the elements, the UI elements, become reactive themselves.
Correct.
Okay,
So you
scroll
create
down, scroll down. You see RX Android here? Where is it?
what line?
There it is, 108. I have it, but I don't use it. I'm using RX Java.
Yeah, but I mean, RX Java is a dependency on RX Android,
I think
so
it's the
it's
other way
there as
around.
well. No, 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 no. RX Android depends on RX Java. RX Java doesn't know Android. It's
Yeah,
completely
exactly.
vanilla.
Oh, I think you
Yeah.
said the opposite because okay,
No, no.
so RX Java is standalone. That's what I've been using for the observables. It's not Android specific.
Correct.
Yeah, so I didn't know I didn't need this dependency. Okay.
Yeah, you probably don't need that because you're not calling any classes from
I'm
it.
not calling. I just now you
Oh,
told
that's
me that.
actually, I don't know if that's true. I think, access to the main thread?
Yeah, I think you need it just for Android threads if you want to spawn a new one and tell it that that's the UI thread.
Correct.
But
I
I
think that's
don't
the
do
only
any.
reason you need it.
Yeah, I don't do any element RXing or widget RXing or anything.
So maybe that's something we can look at.
Yeah, definitely, definitely.
Okay.
All
All right, man.
right. Well, that's a wrap, guys.
Good talking to you.
Same here. See you in the next one, I guess. Bye.
Bye.